So in the last videos we were discussing the preparation of alcohols, and we discussed its preparation from carbonyl compounds. And in this session we are going to solve some practice problems based on the preparation of alcohols from the carbonyl compounds. Before proceeding, we should keep some important points in mind. See, this reagent, that is hydrogen with any of these metallic catalysts, platinum, palladium, nickel, any of these, if we are using this reagent, this reagent has a capability to reduce both the alkene as well as the carbonyl, as a carbonyl group. Okay, it can reduce both the groups, alkenes and the carbonyl groups. It's a strong reducing agent and it has capability of reducing both these both these pi bonds. Okay, pi bond between carbon carbon and pi bond between carbon and oxygen. And the sodium borohydride and lithium aluminum hydrides, these two hydrides cannot reduce the alkene. Okay, it has capability of only reducing the carbonyl. Okay, carbonyl group. So although these both of these reagents are strong reducing agents, but not enough to reduce the alkene. Okay, but if phenyl group is attached to carbon double bond. Okay, if phenyl group means C6H5. Okay, this is the phenyl group, and this is a ring actually. Okay, ring structure we've seen the examples. So if this phenyl group is attached to the alkene, okay, then lithium aluminum hydride, only lithium aluminum hydride, not sodium borohydride, because this is much stronger than sodium borohydride, then this will be also reducing the alkene. Okay, but this is conditional, we have this condition. So we have to check, when we'll be asked questions, we have to check the reagents. If we get an if we get a carbonyl compound which has also an alkene attached to it, and we have been given with this reagent, then both of them will be reduced. Okay, both of them will be reduced. And if we are given only with these, then only carbonyl compound will be carbonyl group will be reduced. And in case the phenyl is attached to the alkene and we have this reagent, then it is going to reduce the alkene as well. Okay, so we'll just look some examples and make these things clear to us. See, we have an aldehyde. This is an aldehyde. Okay, we can we can also write this aldehyde as, this is CH. Okay, this is double bond. We write it. This is like this, C double bond OH, and a double bond here. Okay, so we have a carbonyl group here. This is an aldehyde, and we have been given with the reagent lithium aluminum hydride. Okay, this is a strong reducing agent, and in the second step we have water, means this will produce the proton. Okay, so what is going to happen with this? We just told that the lithium aluminum hydride is not capable of reducing this double bond. Okay, alkene double bond, it will only reduce this. Okay, so what will be the product? The product will be CH3, CH double bond CH, C C O H. Okay, CH 2 CO. Okay, OH. So this will be the product in this case. Okay, now looking at another example, again we have a double bond here, we have an alkene also there, and we have CHO, means again we have aldehyde. And now we are reducing this with lithium aluminum hydride, and again the same reagents we have, but here we have a phenyl group. This is the phenyl group that's attached to the double bond. And as we already just told, that if a phenyl group's attached to a double bond of the means alkene, then the lithium aluminum hydride can reduce this as well. And reduction means just I will write it in a simple form to make clear what reduction means. Okay, it will be like this: CH, CH, COH, Okay, one H will be attached to this carbon, one H will be attached to this carbon, and one H will be attached to this carbon, and one H will be attached to this carbon. So this is the reduction. Okay, so we can also write this as we can also write this as can also write this as okay, CH2, CH2, then CH2OH. Okay, so we have to understand the concept here. We have a phenyl group attached to alkene. Now this will be capable of reducing both the groups, the alkene group as well as the C double bond OH group that's present here. Okay, now let's look few more examples. See, we have an aldehyde here. Okay, and we have got the sodium borohydride and methanol. Using methanol eases the reaction. Okay, so again this is capable of reducing this CHO bond. Okay, we can write this also as CH3 CH double bond C double bond OH. Okay, you can also write this. So this sodium borohydride is capable of reducing this bond. So we'll be getting the product as CH3 CH double bond CH and CH2OH. This will be the product. This is the alcohol that we get in this reaction. And similar example we have in this case, again phenyl is attached to the double bond of this alkene, and this is the CHO group, that is C double bond OH group. Okay, this is the carbonyl group here. Now we know that the sodium borohydride cannot reduce alkene, even if the phenyl groups attached to this. Okay, even if this is attached, it cannot reduce it. So we'll be getting the similar product as we'll be getting the product as CH double bond CH2OH. So this will be the product. So this presence of this phenyl group is not going to enhance the reduction of this alkene here. Okay, similarly this is one more example. We have nitro group here. Again the sodium borohydride cannot reduce this nitro group. Okay, so the product in this case will be the nitro group will be present as it is, and we will get, oh sorry, we have to show the bonds, and this will be reduced CH2OH. Okay, so looking some more examples. Here we have got this. Let me repeat. So similar question we have here. We have an alkene, and there is a presence of this phenyl group here, and the reagents are sodium borohydride and methanol. First of all, we know that this sodium borohydride is going to reduce this carbonyl group, but it is not capable of reducing the alkene even if this phenyl group is present. So our product in this reaction will be OH. Okay, this will be the product. This alcohol will be produced in this reaction, and this is again the same example. That's just for the practice. We can solve it. Again, we have an alkene and a carbonyl group present in this ketone. Okay, this is a ketone, and phenyl is present here. Okay, now we know that phenyl is going to enhance the reduction of this alkene in when lithium aluminum hydride is the reducing agent. So in this case the product will be like this. Okay, so you have a H5 C6H5 here, C6H5 in this case. Okay, we have not shown the hydrogens here, but we should understand what we have written. Okay, now looking at this last example, another typical example that we can get. So this is a compound, this is a carbonyl compound. We have two different types of carbonyl groups in this. Okay, this is a we can take this as a, this is a carbonyl, this is a ketonic group here. Okay, this is a ketone. We have R groups here, and this is a ester group, RCOOR. Okay, this is an ester group. So if we if we are taking the reagents as sodium borohydride, okay, in methanol, then what we know that this sodium borohydride is not going to reduce the ester, because it's not capable of reducing the esters and carboxylic acids. It can reduce aldehydes and ketones. So this carbonyl is going to reduce when we use sodium borohydride, and this is not going to affect this. So if we are taking these as reagents, then our product in this case will be getting the product as this. Okay, rest the molecule will be same as it is. Okay, write it like this. Okay, and if we are taking lithium aluminum hydride and proton, then we know that this is strong reducing agent, and it is going to reduce both of them. It's going to reduce both of them. So we'll be getting the product as we'll be getting the product as alcohol here, and this ring will be opened, and we'll be getting one alcohol here, and another will be getting here. Okay, so this will be the reaction. Actually, there is a similar mechanism for this reaction as we have done for the ester reduction. Same mechanism is followed here. So this will be the product in this case.